Thank you for joining me. I am Trish. I hope everyone's doing well. Look what we have here. Unit circle, x squared plus y squared equals 1. You know the radius is equal to 1. And a linear function y equals minus 3 over 2x. Slope is minus 3 over 2. If you graph these out, it's not difficult by any means. Here's your y equals minus 3 over 2 x, and here's your unit circle. It's not drawn to scale, but when you look at it, what are you seeing? 2 points of intersection. We'll call this point A, we'll call this point B our points of intersection. If you want to determine the coordinate pairs of these, the values of these, if you want to determine the coordinate pairs or the values of these intersection points, you know you can substitution and then take it through, but it's difficult or it can be time consuming and laborious. Let me show you a very quick and easy way. This line here, y equals minus 3 over 2x, has a certain inclination with regards to your x-axis, and you can remember this formula, tan theta is equal to the slope of that line, or of such a line the inclination is determined by tan of that, and you know here it's minus 3 over 2. When you do the theta, you're doing inverse tan of minus 3 over 2. You can bring out your calculator and keep it on the DEG mode. Take 1.5 minus inverse tan, you get minus 56.3 degrees, but when you adjust it with regards to 180, 123.7 degrees. You are looking 123.7 in that direction, but you're looking minus 56.3 in this, and pretty much you're done. It's that easy, and I'll tell you why. Any point on a unit circle is always r cosine theta and r sine theta. That's what it is. This here's your x value, that's your y value. When you bring everything into play for the A and the B point, the point will be r cosine theta, r sine theta, but r here is equal to 1. You don't even need to write it. You're just doing cosine 123.7 comma sine 123.7. When you compute this, you're getting this point A. When you do point B, you know you can adjust this minus 56.3 for 360 degrees, but you don't have to. You can use that. But I will adjust it simply so it looks like a better value, a representative value. I'll add it to 360 degrees, and look what I get. 303.7 is what it'll compute to. It'll be cosine 303.7 comma sine 303.7. Absolutely no substitution involved, and it's easy. You can compute these. You know this linear line is odd function in terms of symmetry around the origin. Whatever you compute over here will be the exact numerical values here. You just have to change the signs. Cosine of 123, here I'm getting a minus 0.5548. And then sine, I'm getting 0.8319. That's what I have. Now for these set of values here, it's exactly the same numerical values. You're just changing the sign. Cosine is positive in this fourth quadrant and sine is negative. This will be positive 0.5548, and this here will be minus 0.8319, and that's it. You're done. Those are your two intersection points. Here's point A, here's point B, and they will be right. You don't have to do any substitution, and it's lengthy that way. This way here it's actually very easy. Just remember this formula. Have a good day. Thank you for watching.